Hey everyone, and welcome to today's video. Today we're going to be talking about optimization. One of the biggest cost of performance issues in Unity happens to be the UI. So today we're going to look at how the UI works and how we can optimize our UI to be more performant. So the most basic component of a UI happens to be the canvas. Now the canvas is the root of all of these UI elements. It owns the meshes that are generated from all the elements that a canvas contains. And the canvas also takes these meshes, sends them to the GPU for drawing every frame. Now the canvas is also responsible for ordering the regeneration of meshes anytime something changes on the canvas, and generating these meshes can be quite expensive. So we need to get Unity to not only do this when something changes and not make it regenerate things that don't need to be regenerated. How do we do that? Well, the answer is more canvases. So I've got this UI layout here of Sudoku game. Now, it's not a fully functional game, but it's enough of a layout to demonstrate and highlight what it is I'm going to be talking about today. Well, the first thing we need to do is we need to break up our UI into what we consider static and dirty UI. Now, obviously, static means something that's not going to change, compared to dirty, which is going to be something that changes, whether it's only changes every now and then to something that changes every frame. So at the very top of the screen, I've got 3 buttons, and those 3 buttons can be considered to be static buttons, which means that once the meshes are generated for these buttons, then I shouldn't need Unity to regenerate those meshes every time. So what I can do is I can click on the outer container for these buttons and add a canvas to that. So when I do that, let me just collapse that for a minute. I can then grab the other elements to that area and just drag them into the canvas, so that everything that's now in that canvas is going to be considered as static, because once that canvas generates the mesh, it's never going to change again, so it's never going to regenerate that mesh. And I could do the same thing for these ones down here. I'm not going to do it, but I should do it. Now these ones do change. They don't change every frame, but they do change. So I do want to keep these separated from the rest of the UI. So I should do it within these sections as well. But I want to talk about the middle section, which is the main game area, because this is a grid layout within a grid layout within a grid layout. Now, the layout groups in general should be avoided a lot of the time. Now, I've used a grid layout in this scenario because I wanted to create my UI and make it look good. And rather than sit here and calculate this and calculate that, I've used the layouts to basically generate all of that for me. So once it's actually generated, what I should do is then switch that off, because it's no longer needed. Now I could, if the screen rotated to the portrait mode, I could use it that way, but I would technically recreate another canvas and do exactly the same thing, and only switch to that canvas instead of regenerating the layout. Now, the reason being is that layout groups are more expensive, because when they get dirty, now I should explain that every time something gets dirty, everything is regenerated. But with layout groups, it's not only just regenerated, it's recalculating what's going on within the UI. So it's recalculating everything as well. So it's got that added bonus. But on top of that, the way it works is that it goes back and dirties the parent layout group and that parent layout group, etc., etc. And to do that, it's using link queue and get component under the hood. So if you've got a layout group and a layout group within a layout group within a layout group, and you've got thousands of objects on the screen with all of these layout groups, then that's going to be very, very heavy on performance. So you want to try and avoid that as much as possible. So you just, once you've created the layout, switch it off because it's just no longer needed. Now the other thing too is that in this case here, I've got all these images and really they don't need UI events. So you really want to turn off raycast target and make sure that that is off for things that you consider do not need the UI event. Now, in this particular case, I don't need that raycast target on anything that I've got on that screen. So I've turned it all off. The reason being is that I'm actually taking care of all of that underneath the hood, with my own code. So basically, if I press a button, the code is saying, hey, you've been pressed, do what I need to do. I'm handling those events myself. What else is there? Oh, yes. Now I haven't done it, but these, as I said, these three buttons up the top, the theme button would pop up another window, which will then have other things in there to be able to select. The pause would then throw up a window, which would then blur the background and display a blank something blank over the top of the canvas. And the settings button is another window, again, with options. So basically what I'm saying is that if you're designing a game, you may have a main menu, you may have a audio menu where you go in and change all the audio settings, you may have a display, so that you can go in and change all the display options, whether it's VSync, the resolution, etc., etc. When you do this, normally what you would do is you would have them grouped hierarchically with a game object that says that this is grouped by the main menu, settings, etc., etc. And you would then turn that particular game object on or off, depending on what it is you're going to be displaying. Well, have a think about, instead of doing a game object, do a canvas instead. Now, the reason I suggest that is because when you turn a canvas on and off, when you turn a game object on and off that's in a canvas, you are basically telling that canvas, I'm now dirty, regenerate that mesh. But if we do it to a canvas, the canvas has already generated that mesh, so it's not going to regenerate another mesh. You see what I'm saying? So we can turn around and make the UI more performant by doing that as well. What else is left? Oh, pooling. Now, obviously, if you're doing a card game, like Solitaire, Klondike, Free Cell, and those type of card games, and like the Witcher card games, and card games like that. When you do UI, because a lot of these can be done with the UI. Now, a lot of games do what we call object pooling. So what that means, if you're not familiar with object pooling, it just means that all of those objects are created at runtime, at this very beginning of the game being run, so that we're not doing that when the game is running, because reinstantiating and creating things on the fly can cost us in our performance, particularly when we start deleting them and regenerating them and etc., etc. So we look at doing object pooling. Now with the UI, again, with what I was talking about with the actual game object, when you're turning and disabling the game object, it then turns around and dirties the canvas and it regenerates the mesh. Well, object pooling does exactly the same thing. So reparenting something and removing it will do exactly the same thing. It will dirty the canvas. So what we want to do is, if we're going to be doing this, what you should be doing is actually disabling the object in question first, then parent it to what you want, and then re-enable that object. And you want to do the reverse when you want to remove that from the parent. You want to disable that object, remove it from the parent. Now, when you do that, it's not going to trigger a dirty canvas. The only other thing left to really talk about is the world object canvases. Now, with world object canvases, I've got this background image here. What I'm going to do is I'm going to very quickly create a canvas just to highlight what I'm talking about. And I'm going to drop that into here. And I'm going to make that a screen space. Now, you'll notice that the render camera is empty. You can leave this empty, but be warned, it can cause performance issues. Now, every frame, this needs to be tied to a camera. So Unity takes, it looks at this and says, oh, okay, well, you haven't defined this, so I need to know which camera this has to be attached to. And it goes off and does a camera.main call, which we all know is a code to go and find the camera. So you've got a performant hit there straight away. Now with world canvases, so like if we go and select this as world space, then there's an added cost. Now, I want you to have a think about this one for a minute, because when Unity does this, it can make these calls 7 to 10 times every raycast. So every raycast that you've got on that is happening on your screen, it's calling this 7 to 10 times. Now that's for every world space object. So if you've got 100, let's say you've got 100 objects on the screen, and they've all got their own UI, which shows you what their health is. Now you imagine that's, say, 5 or 10 raycasts per object. You've got 35 calls per object by 100. It soon adds up. Anyway, that's pretty much all I wanted to have a discuss today and to showcase. Now, I am going to drop a link in the description, and I do recommend that you go on and watch this video. It's by Unity. It's a fairly lengthy talk. I think it's this particular section is roughly half an hour. But it goes into more depth. So if you're really technical minded and you really want to know the under the hoods as to what's going on and better explain what I've talked about today, please go and watch that video. For everyone else, this should be enough to get your game optimized. Till next time. Well, we've come to the end of another video, and I do thank you for watching. If you did enjoy the video and would like to help support the channel grow, then please do subscribe. And to get notified of new content being added, make sure to press that bell.